Morning to all. So today we will be doing the tutorial session. First, we will be doing simulation of water. Okay, in GROMACS. So round 2 will instruct you how to go by step. You just follow him, and okay, whatever the problems, then he and Mazar will correct. Right. Okay. So I am there at the back. So round 2, let's start.
So good morning, everyone. So we already started the water problem, right? I just give a quick review and again start from there. Just what we did first, we create Avogadro. First, we create a water molecule from the Avogadro. Then we energy minimize it, then save it, and then we edit the file using PDB in text file. Then what we did, we prepare the force field of Avogadro. Okay.
I mean, okay, first show one slide and ask everyone to perform that job.
So already done. So next week we already created the force field using PDB to GMX command. It's already also done, right? Then we use the insert molecule to insert the 3000 water molecule in a box, right? That's also done. Then we edit the topology.top file to let the water molecule be 3000. Okay. Then we will start there from the em.mdp, management.mdp, which is already I sent tomorrow. And please download that file em, nbt, npt, and md, and put it same folder where is the water.pdb is present.
Rest of the thing, PDF, kindly download it and kindly save it in the folder where you have the list of the file. Is everyone following the process? Yeah. If you're finding any difficulty in this package.
If you don't find it, then you take a notepad and write this one. That's another way. समझने के लिए होता है.
System के बनी सी लगे वाटर सप्लाई बॉक्स तेरे लिए में कॉपी करने की आवश्यकता नहीं पड़ेगी. ठीक
है. Everybody created the em.mdp file. Can I move on? Okay. So after that, we create the use the GMX GROMTP command, which take three files. One is MDP, another is topology interaction file, last one is the coordinate file. These three files prepare prepare and take one TPR file, which is the essential for the run input or MD run. It is a binary file. You can read if these three files combine and prepare one binary file. That's all the command. Do it. And
Yeah. Use the real command. USR is local.
GROMACS
please do it. Write that comment first, then use that.
I think everyone has the thing also at the file.
This one first in terminal, then you start with the Next, you will, if you type the ls, you see that EM ticket has been generated. Yes. Okay. Next, to run the energy minimization, use this command: GMX mdran -s em.tpr, which is take the tpr file, and dev name em -v. For dev name is used to compute the same name each file. GROMACS not only give different file format, which is already a C mode, sorry, initial lecture.
Energy minimization step. That GR file that we have generated in the previous TPR file. This is for the generation of the file, that is the TPR file. And now after generation of the TPR file, now we have to do the energy minimization. Okay. I think so. Everyone have done till here. Now we will follow for the energy minimization. Check it whether the TPR file is being generated. Okay. Now use the following command for energy minimization. This energy minimization.
Can be able for moment that you can read down the data in the set if the TPR is the input for the energy. And then when ls m star is when m star will get the part of the yeah. Everybody done that? Okay, I will move on next step. So then you see that after that run completion, it will say that the stabilization converts maximum in number of steps for each equilibrium. Then the potential energy, how much that time is the potential energy, and maximum force, which is less than 1000. Then another gradient of that. If you successfully run, then this kind of comments come. GROMACS reminds you something, right? Then Then if you type the LSEM star, you will see that what are the files generated using energy minimization. .edr, .gro, .log, or .trg. Among them, EDR contains the energy file data. .gro is the final coordinate after the energy minimization. .log is the forces which is showing in the screen, which will be written in the log files. And .trr is the trajectory file where the coordinates set. Till now, em.trr is empty. In NVT or NPT, we will start that TRR will be filled that. LSEM start. then you will see that there is 4 files generated. One is em.edr, another em.go, em.log, and em.trr. In EDR file contain the energy data. In Go file, which is the after energy minimization last one, and log file, what is showing the screen that data read when you done the energy minimization problem. And TRR is the trajectory file where the coordinates will be written, but in energy minimization there is no coordinate in TRR. It will start in the NPT and NPT. Okay. So I can move on.
Not having a doubt that while we have taken below 1,004,
Okay. See, here what we take the maximum force is 1,000, right? Why it is 1,000? Not 10, not 100, not 2,000, not 5,000, not 10,000. Why it is 1,000? When we take the complex molecule like protein or polymer, it will be clouded. It will be from cluster form structure, right? So when it is cluster form, the energy will be rise up. If we decrease the temperature, the energy less than 1,000, say 100 or 10, it will be when energy minimization started in some step, it will go to that position where energy will be increased, and it will doesn't minimize that. That leads to error in equilibrium. So what we see at the trial and error method, that 1,000 is the best suitable value for any material. And after that, we can follow the next step. For each small molecule, we can take the lowest value, say 10 or 5 kilojoule per mole. But that doesn't affect on equilibration run further. So after that, I think actually that's that part completed anyway, right? Next is this one. How to analyze the energy file? Is it created? So then you have to write that command which is given the potential energy from the energy file. And if you plot that potential energy, you will see that the graph, which graph shows that the energy has been potential energy has been decreased in step. Right. Writing this command, then select 4 and space 0. Okay. Because 4 for potential energy, you can plot other data, but for energy minimization, important parameter is potential energy of the system, because that time we did not give the kinetic energy of the molecule. So that's why potential energy is important. We further go and see that it will be generated on the directory potential.xvg. Then we open it notepad and copy the data and plot in Excel, because there is in Linux it will be the XML, so it will be the easiest. But here it will be no graphing software, I don't know, so it will be plot in Excel. That 2-column data. These two data total. No.
Okay, kindly repeat this step if you have not followed. Okay, I think so. Everyone has done this one. Okay. File generation. And the potential dot use this command to generate the energy for file. Okay. We will get a file that potential dot xvg. Okay.
नहीं वहाँ पे एक्सेल यहाँ पे एक्सेल तक
So after plotting the potential energy, we see that energy has been minimized and go to the lowest minima. Then next is equilibration. So open the nvt.mdp file, which is I send it using VI or Notepad. For me, Linux is comfortable, so I use VI. For your case, I totally recommend Notepad. Did you open the NVT state? Okay. Then check that step. Okay, this is very important because here it is considered as a time. How much you step, you will be computation. If you give one extra zero, it will be go 100 picosecond to 1 nanosecond, and it time will be the 15 to 20 minutes to 1 to 2 hours. The step is very crucial here. And the second thing is this control parameter, output control parameter, because it determines your storage of the system. Because we do not have unlimited storage, so if we can give these parameters too close, it will fill the storage quickly, and it will after certain time it will stop the simulation. So we have to copy that data as such way that the storage will be the optimized use, and we further you can use. For this 100 picosecond NVT equilibration, we use the 500. Means every 1 picosecond we save the coordinate. So we get total each time 100 points. Okay. Change this to thing. 500 is an step. 500 into 0.02. That's what's the step? Yes. That's a step number. When it is multiplied with 0.080, it will be 50,000. Okay. So then in that script, you see that first is integrator, which is MD. That's mean leapfrog indicator. When you use energy minimization, you see the steepest steep use, right? For energy minimization, we can use steep and conjugate gradient. Among them, steep is fastest and quickest. conjugate gradient will slowly move and the energy will be decreased slowly. But last moment, when you see algorithm, you see that fluctuation has been a long time taken, right? When potential dot activity, plot, but conjugate gradient it will be the smooth. That's the difference. And for in equilibration, we have to use the leapfrog because leapfrog algorithm is compute the forces. Okay, next thing is the step. It is the most important parameter. How much time you require to system equilibrated, it will be determined that state. Because for what if you give it randomly, your system will go to the long time or go to the very small and system will not equilibrated. Next thing is the time step. Time step is the 2 femtosecond. Here you can use 1 femtosecond in classical ND, 2 femtosecond, 4 femtosecond, based on the system and based on some literature. Some literature for 1 femtosecond, very small, very say reactive type, too much frequency interaction happening. There we should use 1 femtosecond. 2 femtosecond majorly use, meaning protein, macromolecule, water, every 2 femtosecond. But 4 femtosecond also use for, I think, I never use actually 4 femtosecond. But I one system I remember, but I don't right now don't remember used. Then is the output control. Output control NHT X out for the coordinate, V out for velocity, energy NHT energy for energy out, and log update the log file for NHT log. These 4 parameter is determine your storage system. How much you want to use for the equilibration. If you give too much short, your system file will be the very long. If you give too small, too large, then your system file doesn't get that much data. Then your statistical average data will be the it come to error. So this file also we have to think and then give it. Next is the bond parameter. First is continuation. Says no. Is after that step, after energy minimization, can we give the any molecule movement started? Answer is no, because we didn't give the temperature. Right? So this is the first dynamics. So that's why it is called no. After NVT, we always write that yes, because it is the next NVT to continue doing it. After NVT, it will continue, right? So it will be writing yes. So it will carry the previous velocity and the next simulation. Here there is no velocity present in that simulation box. Next is the constant algorithm. Is the links. What I already previous in lecture we already said links and things different and whatever PPT is given. Next is constant hydrogen bond. Why hydrogen bond? Because hydrogen is a morely frequent bond and it is frequency much higher. You can take the all bonds, but hydrogen bond will be the efficiency to enhance your computation speed. Next is the link iteration. How much iteration it will be needed? 1. And order, which order you want to compute, means 4th order derivative we want to compute. Next is the cutoff scheme. Cutoff scheme for Varlet already told previous day. And type to cutoff for the grid spacing. List of update 10. It will be debatable actually. In GROMACS, there is some algorithm based on your system. This NHT list automatically update. For I used for GPU that I saw 100. For supercomputer, I used for 150. Automatically it will be update. And for local computer, 20 or 30, it will update. Based on that, it will be the also speed depend. And Coulombic cutoff and RVW cutoff for short range interaction. For Coulombic cutoff, it is 1 nanometer and one thing, GROMACS by default unit is nanometer. So 1 nanometer and RVW is 1 nanometer. How I get that parameter? It will be the based on the force field data, which you force field used. That data, how much data is used to compute the efficiency of calculation. For generally OPLS, it will be the 1, AMBER 1, CHARM 1 and 1.2. And I think AMOEBA 1.2 and 1.4. And the disperse correlation, it will be the energy and pressure. Next is the Coulomb type. For the long range Coulomb type cutoff, we will use PME. Because Coulombic interaction not straight for the 1 nanometer. After that 1 nanometer, there will be the interaction. Right? So how we compute that? Because in Coulomb interaction, what we say that F equals to Q1 Q2 by 1 by R. This F is directly proportional to 1 by R. If some function Coulomb cutoff came with the R square. So what is the function? F equals to R, right? If we integrate it, it doesn't converge. It will be enhanced to n to the power. So solve this problem, it will be use the PME algorithm. Next is the PME order, fourth order. It's also the third derivative. And Fourier spacing is the 0.16. This is the another important part. How accuracy is the calculation, smooth or accuracy calculation. It will value depend on 0.12 to 0.16. If you use 0.12, the grid will be the 0.12 size, and if you use 0.16, grid will be the 0.16 size. And in between them, there is no guarantee. Different group use different. And based on their, if their computation speed has been increased or decreased. Next, for temperature couple, here we use VD scale. VD scale is the one of the fastest computation to minimize the energy system temperature. And next is temperature couple groups. Here is the system. I think check that one. I think that's the 14 non-14 will be there, right? It will be the system, obviously updated. Everybody get that? Okay. Next is the tau t. It's the 0.1 picosecond. Means how much frequency you are in NBT equilibration temperature. After how much time the temperature will be the managed or velocity will be the managed, because in simulation it is a blank box. You based on velocity your kinetic energy and temperature defined. Based on temperature, sorry, data temperature, kinetic energy and velocity will be defined. So this parameter also crucial. This parameter take from the literature. There is no way. And the reference temperature of the system. Which temperature you want to work? 300, 400 or any temperature you write. Then pressure coupling. No, that should be single. Yeah. Yes, that's the thing. After tau t will be the single 0.1, not 2.1. That's okay. But it will be rather how many systems you define in index file. Actually, because there is several ways to do it. I didn't go to index file till now. When you give the index file, so can you can count to different. Suppose you have 5 molecules in one box, right? So one each can give them one index. Suppose we have no, if you all over take the temperature of 300, that is the way. If you say no, tau is the 0.1 then yeah, because when you write simulation on the protein, simulation is not by default or the normal chemical system, we have to write then pressure couple is the no, obviously, because we do not perform NPT. periodic boundary condition XYZ. Here all dimensional molecules will be go out and then come. Next, Genval, yes, because this is the first simulation we are doing where velocity has not generated till now. And Gen temperature also. Based on that temperature data, we generate velocity by Maxwell-Boltzmann distribution. It generated total 6 velocity data. Among them, they choose randomly one velocity for each molecule. Huh? No average. It generates 6 velocity probability. Among them, it randomly chosen. So when you run next time, it will be the not matching the same data. So to go to the same data, we have to check that random seed. That seed will be the similar. To rerun that same data. Okay. Next. Okay, that's the end of the script. And save it. Whatever update it after that. And next, go to the NVT equilibration. For same comment. After energy minimization, this is the common command actually. Just change the script, just change the C, P remains same, O will be the different. That's the factor.
This is a different command.
No, same command. In em.mdp, we also use that em.tpr generated. It is actually generate the TPR file, nothing else do. If their system is scan error, it will identify that time.
Okay.
Everyone done that? So next is same command. You see that ls to generate the md.tpr. And next again GMX md run. Same command to generate the md run trajectory. For S for the input file, def name to generate the all the file names same name, and minus V for visualize the system. Write the minus B, you will see that how much time required to complete the simulation, right? I think 2 to 3 minutes per 100 feet per second. Everybody running that? Okay. Hmm. After complete that, you will see that how much time taken code, wall time, and how much nanosecond per day, and how much nanosecond per hour, and what is the fraction used in OpenMP. So that is based on your system. If you use for this system, I use, I think, i3, my laptop. So it will giving the 400%. And that's 34 nanoseconds. It's quite good actually. Although I think I system has contained 5,000 molecules, 15,000 atoms, it's quite good. 34, 35 nanosecond. It is the speed we'll be seeing that. Okay. Already completed NVT equilibration. Done. Next is the after writing the ls NVT star, you will see there is several file extra added. Yeah. Okay. So in NVT star, there is several files. First is nvt.cpt. This is a checkpoint file. What it did, suppose you run a simulation and your electricity is down. You have to again rerun. You have to again start the first simulation. No, you can rerun it from the CPT point. Next is nvt.edr. It contains energy data. Grow after NVT equilibration. What is the final coordinate? Log. What are the data you will see in the screen? That will be the remaining in the log. And nvt.trr is a trajectory file. Here you can visualize it. TRR is a complete trajectory. Where is the velocity, forces, motion, everything will be written. And XTC is the compressed trajectory, where only written the coordinate and velocity coordinates, no written the force. That's why if you check the space, NVT TRR is a much higher space.
XTC and I think NVT previous तो नहीं आएगा. That is for us continuation. I think you can say what.
So if your file is not generated, do not need that right now. What we need, if it is not generated HTC or in PTP, PBT, if it is not generated right now, do not need that. Yeah, checkpoints.cpt is an to restart the simulation. Previous CPT is that's previous step. Actually, in HTC has one of the major advantage of the GROMACS, because in VMD, in local computer, we do not have much code, right? i3 or i5, or for system analyze, we used, I think for simulation, 60-70,000 atoms is common. So HTC file is easily loadable, but if you load the TRR file in VMD, your system will be slow and it takes so much time because there's content totally force data. So if your atom is the suppose 3,000 atom you taken, means total 9,000 component, then each component has 3 force dimension, 9,000 into 3. Fx, Fy, Fz, 27,000 force component each step, and how many steps you calculated, that much data will be the present. So that's why TRR is a too much low. And there, if there is in HTC file, there is no present of the force. So due to that, that loading is the fastest. That's the difference, nothing else. You can convert that TRR to HTC. Yeah, I will tell it later. Right now, I not tell it. You can generate it from the TRR to HTC. I will show it later. Okay. I hope everybody completed the NVT. Next is you can analyze the nvt.edr file and check the temperature data using GMX energy command. Will I give that side? Yeah, this command you can check the NVT data. How the temperature has been changed with time. Actually, when you system prepared, after that, this 2 or 3 command will be the frequent. No. After that, choose the 9. Because 9 is the temperature, right? We had equilibrated what temperature in NVT. Okay. After that, for moving on, if we see that there is temperature.xbg, and if we open that notepad and plot in Excel to check how the temperature deviates during the simulation. We further move on. Yeah, next is NPT. So same parameter, step will be the 50,000 and time will be the 2 femtosecond. I think not 100 picosecond system will be equilibrated properly. It take more time, but Here in time constant, we have to see that 100 picosecond. Okay. Step will be the 50,000. And this port data. This port. P couple is the here we use Perinello diamond. Another one of the fastest pressure coupling algorithm. Yeah, P couple type isotropic. Here it will be based on your simulation, you can change. Because if you want, there is GROMACS several option actually. You can calculate surface tension, you can calculate for constant stress strain MD. That data will be the change. You have to check the manual and that will be the change. And tau P is the time constant for pressure coupling. It will be the 2. And reference P in bar, accurately 1.01325. Moderately 1 is sufficient. And compressibility, it is the water compressibility value, 4.5 into e to the power minus 5. And rep for scaling, how to scale the pressure parameter. It is the center of mass, COM. That's two written. And next step, you will see that gen vel equals to no, because already velocity has been generated in NVT equilibration. And I think, that's the thing. And one another change is the continuation, right? Because we simulate restart the NVT. So here it will be the yes. Previously in NVT script that will be the no. Right? Check that in your NVT script and edit it similarly. And one more thing, VD scale will 14 not will be the 14, it will be the system, right? The system.
Yeah. The extra management provided in the section of the just be right.
And also, if this person is also data. Non-wanted setting. Non-wanted setting. Wanted. The neighbors are.
Please kindly make the changes. It is temperature coupling. There is TC dash GRP. This here it is. We have written as make it as 16 because we have written. And the rest of the thing leave it as it is. Don't worry, we will just.
Because
Advanced NPT is running.
Everybody take the NPT script.
non-wanted setting not for a problem. No, no. We have not decided that. Non-wanted setting. Non-wanted.
Over there at the industry.
No. When अभी
उसका प्रॉब्लम होता है
ये वाला नहीं भेजा हुआ है कि कल रात ही हो गए
कल रात में क्या
ये वाला मैं लिखना चाहता हूँ इसमें इसमें कोई समस्या कोई विषय नहीं अरे वो वाला नहीं बोल तो उसमें क्या करेगा वो वहाँ पे देखिए फाइल फॉर्म में कितना अगर वो ही है फाइल का क्लिक नंबर नाम ये है हम रोज ये वाला बढ़िया फाइल को वही बात बोल रहा है
So I hope you already did that. Did that?
No. ये वाला वो जो पता नहीं उसी का जो उसको इसके हिसाब से बता नहीं है बाबा एक काम करो सबमिट वो व्हाट्सएप लॉग किया था आपने वो एक बार चेक करेगा
Those who have completed this script, they can use this following command for running, and rest of the thing. हाँ पीछे का दिखाना And try to run this one. For make one correction. For the system that we have done, we have GMX MPR, we have MPR parallel we have done. So there might be in your system there is no parallel computing is available. So write only GMX, don't write space and MPR. Just leave that line. Okay. Write GMX. It will not create any problem. Just GMX. Yeah, that's for MPR. It is not found because most of the in most of the system no MPR is strong. Please only write GMX and try to run it.
Error. Protein reference in the NPP file will not find it.
Protein system.
प्रोटीन दिया हुआ प्रोटीन का सिस्टम करना है even in the good protein reference is not in the
तो इसमें सही बात करना पड़ेगा जो मैंने इससे बस ये डिफाइन को हटाओ ये डिफाइन को चेंज करो
Next command is GMX MD done minus S NPT dot TPR def name NPT minus B. Meaning same hota hai every time default visualization nothing else. And do not write MPI. Okay. It's GMX.
Take some time.
তাহলে তো তাড়াতাড়ি হবে একটা বলে তো নিজের থেকে আমি কিছু করার পরিস্থিতি হবে না ওটা মনে বড় সিস্টেম আরো বড় সিস্টেম আরো বড় মানে আমি বলছি আমার আমি এটা ইউজ করি আপনি মাফ করে ক্লাস্টার আমার কনফিডেন্স 4,000 হ্যাঁ 4,000 রয়েছে 4,000 এটি ক্লাস্টার এটা সাউন্ড ব্যাকগ্রাউন্ড বড় সিস্টেম and all what the highlight what the चार টাকা আরো বড় যে কি হবে আর এটা একটা সোর্স আছে এই তো ভালো নমস্কার করা ভালো यहाँ पे कहाँ से देखना है हाँ अच्छा वो जो टेक्स्ट एडिटर चला गया तो मीम अपनी प्राइस दी नहीं जा रहा है ठीक है ऐसा नहीं आ रहा क्या और डी लिखने से अरे सीडी हो गया ना सीडी हो गया अभी जी लिखो ना अपने बात बात उनको बोल रहे हैं ये वाला पार्ट से उनको वाला बात में समझा ये ना नॉर्मल रनिंग कोड है नहीं हम ये वाला दिक्कत एक्चुअली नहीं यहाँ पे हम मैंने पूरा एक्सपेरिमेंट देखने का है मेरा खुद आ गया अच्छा अगर नहीं काम तो नहीं नहीं अभी शांत हो सब कुछ किए इससे पहले तक सब कुछ किए हाँ इंस्टॉलेशन हाँ इंस्टॉलेशन जी कमांड चेक करेंगे कितना टाइम लगा हाँ 100 लिखा होगा ना 100 भी कुछ नहीं वैसे ओपन करो वैसे इसमें इंस्टॉल होगा हाँ वो मिनिमाइज करो nvt mpt mdp है mvt.mdp mvt mpt.mdp mpt नहीं करेंगे nvt
एलपीटी
अभी तो एलपीटी भी
हाँ तो एलपीटी डॉट एमडीपी एमडीपी
हाँ ये
एलपीटी डॉट एमडीपी
हाँ
इसमें एक जीरो और बना दूंगा मैं टाइम से बना रहा हूँ 3 मिनट में बनाऊंगा
लगा के चला जाएगा
फिर
तो चला देंगे हो जाएगा
चल यार चल तो पहले
तुम वो वाला जनरेट किया सबसे पहले 95 हुआ अच्छा ओके npt.tpr डेफ में ये वाला तुम किया कौन सा कमांड की तो तुम नहीं बोल रहे लेकिन लास्ट में npt का mdp है वो सी के npt हाँ ये npt.tpr करना है npt.tpr बस जरूर 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 इंस्टॉल इंस्टॉल नहीं किया इसका चला नहीं किया सब काम कर रहा है कौन सा टीडीएफ में वन में नहीं बैठा हुआ वो टीचर कोर्स किया ना स्टार्ट से नहीं किया उसमें तो थोड़ा भेजिए था किया था ना तो पैसे डाउन करते हुआ ये वाला चला है ये और ये मैंने ये गंभीर चला ठीक है ये एनपीटी को चलाएगा एनपीटी दिया था वही बनाए ठीक है वो इनपुट फाइल बनाए ठीक है फिर आप उसको पुट करेगा एनपीटी में उसको 50,000 से 500 से 50,000 नहीं हो रुक जाओ रुक जाओ रुक जाओ शांत हो जाओ भाई अपना भाव नहीं करते वाला से किया था सुनिए मेन जो चीज सेट करना रहता है लटक जाएगा उसको चलना भाई है ना एक बार तो तुम पास वाला जब कमांड में जा पा पानी अभी गलत सोच कुछ तरह सेफ भी रहना चाहिए धीरे धीरे समझो
Okay. तुम्हारा practice है। Just बहुत सारा practice।
So I think NPT run will be the completed, right? So you will see same thing, how much code, how much speed and clock speed and data available below. Then you have to check that either your system will equilibrated or not. For NPT, you will check the density because your system desired density not came. So your system will be there. You have to need extra simulation run, or else case your parameter will be should to be changed. Okay. So this is the one of the measure, and do not write the GMX MPI. Okay, write GMX.
Till here we have completed. So before leaving, we have gone through this step now. So this step we are following.
So after writing this comment, we should write the 16 and 0 to calculate the density and plot it. So we know that water desired density is 1000. And in GROMACS, one of the beauties it came to the SI unit. So you have to check that. If it is not come, either your parameter wrong or you have to run the long simulation. So the MPT plot already done, did it? Okay. And the value, what is the value? 6,000. So your system is well equilibrated. Okay. So in NPT, you can come see other things also, like how the volume changes with time, because in NPT your volume is being reduced, and pressure, because NPT in pressure will be the parameter, and others also parameter you can check. So after completing the NPT, we move on to the production speed. Here it will be the 1000 picosecond by 1 nanosecond. I will recommend 500 picosecond for running to calculate the property. So this step will be the 25 and 10 will be reduced. NP.NDP, the final production. Production script. Here production script md.mdp. From that data, we calculate the every property after equilibration. Production samples. No, 1 nanosecond. Do not do that 1 nanosecond, because 1 nanosecond it take, I think, how much is the speed they are giving? 34, right? You can take 1 nanosecond. Yeah. MD.NDP. What is that? 11 minutes. उससे कोई नहीं मेरा पहले दिन का देख चेंज करो system and tau t 0.1 and 300. That's that change we have to do. Yes, continuous range, yes, because you didn't know the fast dimension. So fast dimension is NVT, then you use basic NPT, then you also continue the production.
OPLS space production capital भी आ रहा है.
Okay, modify this script. Yeah, this will be the system, right? This will system, this will 0.1 and 300. This part is not present. And this will be the system. Okay, after that, same command and save it file. After that, same command. Take the GMX GROMPP minus F md.mdp p tuple.top c npt.row and o md01.tpr. You can give it another name. That's totally depend on you. हाँ 100 second तक हो सकता है. That is the possible because 68 giving right data. It's the same. And after that phase enter, you will see the MD01 TPR will be generated. Is there any error come? There is no error come, right? Okay. And after that, MD done. GMX MD run is for input, dev name to generate every file, and V for visualization. Yeah, this.
Oh, MD जैसे आप कोड रन कर रहा है तुम नहीं समझ रहे हो अरे इसको समझ में आ रहा है
ये कुछ हुआ था कल तो मत किया हमारा ध्यान थोड़ा अलग ही टाइप का है तो यहाँ पर भी सीरियस नहीं रहेगा वहाँ पर क्या है वो वाला
तो मार्जिन वाले बीच में भी ऐसे करती है ना कि बिल्स अप कर देंगे बीच में तो मेरे को वो डर लग रहा था सोशली स्ट्रेस हो जाएगी और ये तो ये तो हेल्थ सब होता तो करता है बीच में मतलब फिटनेस से थोड़े ये जो ना फिर तो फिर कुछ उस लाइक भी ऐसे लाइक फॉरेन म्यूजिक से आप रहो यार तो ऐसे अब तो आप भी ऐसा ये इमेज प्रॉब्लम ही बहुत अपना कुछ प्रॉब्लम हमें बता रहे हैं कैसे लग सकता है मैंने केवल और बाकी अरे मगर लिखिए कि चलो ऐसा तो लाभ बिल परफॉर्मेंस पिच में नहीं 100 परफॉर्मेंस स्प्रेड भी गाइड वन and the part is someone yeah, that's also I don't think finally yes.
So if everybody completed production run, so we will wait until that's completed.
And then actually need to check.
Whether your system is having VMD or not. VMD are doing visualization and we are doing what if you require VMD? It doesn't have to use any VMD.
Extensive is what are the names of the video? Extensive.
Okay, I think let's begin. अभी तक नहीं हुआ ना? ठीक है, स्टार्ट करते हैं, जितना होता है उसके बाद हो जाएगा. Next, you will see after completion there's kind of how much performance already. Next, open the VMD. I will see telling it how to do it. Open, everybody. Next, load, go to file section and new molecule. No.
वैलिडेट करना पड़ता ना ज्यादा
right? Select it. Then browse and load the npt.grow. Browse and where is npt.grow? Already you run. Load that. ना उसके दौरान नहीं अभी बहुत का एनपीटी हुआ है ना तो बहुत का एनपीटी रन नहीं हुआ है ना अभी तक चल रहा है ना गाने अच्छा तो इसके लिए npt.grow open browse and click the browse. You will be see the come and load where the npt.grow present. npt.grow will be always present, right? And load it. And BMD automatically update the file type. That you do not need to decide. It will. Okay. Next thing, again go to the click the browse and load md_01.htc, but whatever you name give it, md01.htc or what, whatever. md_01.htc or md01.htc or whatever you name give it. After that, loading. Then again load it. Yeah. First load the npt.grow. npt. Then after that you see that it will be showing some figures in BMD screen. Then and load file for that will be the present 0. Here in npt.grow will become for your case. Then file name again browse and load md01.htc and load it. Right? Okay. And next thing, after complete of the loading, you see this kind of line schemes. Why not? ऐसा हो ही नहीं सकता है एक भी नहीं है
आपका आगे दूटो लिखो सागर दाও একটাই ফাইল লাগা তো এনপিটা
आ गया कुछ डेटा आ गया कुछ डेटा आ गया नहीं ना कुछ ना आ जाएगा md01.grow md01
एसपीटी ग्रो
npt grow then उसके ऊपर md_01.xt so
एनपीटी ग्रो डॉट कॉम এবার ওটা দেন
npt.grow, then above that md01 XTC. So there will be the show the frames, number of atoms and volume. And so
जल्दी आता है
इतना तो आ गया क्या तुम्हारा 16 की इसी निकल
जितना भी मैंने किया एकदम फटाफट ये लाइन आता ही है फर्स्ट टाइम पे. So these lines come for PVC system. Okay. So after that, we will move to the analysis. So in MD simulation, you can calculate two types of property till this tutorial will cover. One is structural, another is transport. So for calculating structure property, you need to just take the same box size, which is the two coordinate we will get. One is wrap coordinate, another is unwrap coordinate. For structural property, we will calculate using wrap coordinate, and transport property we will calculate the unwrap coordinate. Right. So to produce the wrap coordinate, use this command. This command will be the generate your wrap coordinate and remove the periodic condition, which is the straight lines. And even same command is used for converting the TRR file to XTC file. Just it will be a TRR, and there will be the output you want to what you want to do, XTC or TRR. and select system. System 0. Select a group. Here is written in 0 system. To it will be the remove the whole PVC. You can remove the PVC individual component. It will be the more complicated system, not small bus. This kind of system it will not be required. For complicated 2-3 times DNA proteins and so much system, that will be remove the 2 to 3 times PVC. I know everybody's selection has been completed. And after that, this command write 0 to remove the PVC. Okay. Next, again we open that VMD using the MD01 Go and MD no PVC mole HTC to either remove PVC or not. It is removed. Okay. Not removed. No. Next, again you have to load it. New molecule. Yeah, new molecule to load it. Again you have to load it. NPT row started. NPT by MD01 row. Everybody, I think, completed MD01 row, right? MD_01 row. Or NPT row, you can continue. again to new molecule and load it file. So you see that the PVC condition lines are gone all. From that you can visualize. For visualization, you will go to the graphics menu, and the graphics menu, there will be the option. So I think I'll see it. Okay. Yeah, graphics and tab. There is on one tab called representation. You can choose the draw style and selection and change it whatever it is. And CP2K, BDW, ball and stick. There is several model available. You can try. Okay. After that, loading. So next is go to the extension tab and analysis and plot the radial distribution function. It's after plot, click that RDF. You will select there your choose that molecule, current molecule. There, this tab. Click on this tab. Use molecule tab and select first. Then next thing is the selection 1 and selection 2, means which atom or which molecule you want to plot the RDF. And first is the 0 or first frame, which frame to which frame you want to start. Last -1 means every frame. If you change it, you can do it. And the maximum R is the what is the maximum distance you can take. For RDF, I say the best way to go to take it the half of the box, but general paper is represent 10 or 20 angstrom is sufficient. Then you can display the GR or display the integrator. You can click it, and if you want to save it, to save to file for further plotting the other graphing software. That is the atom name. I think you remember when I do it. Huh.
So in my case, it is that NPTGR also.
So okay, whatever. Fundamentally same. Okay, then compute GR. Click. Yeah. Selection one name for OW. Here is for atom. You can analyze for based on molecule, atom, or residue specifically, or you can take serial also. There is in VMD there is several option actually.
People who are
Okay, then compute the GR click, and you will see that type of kind of one graph coming. This is first RDA, and this is the first peak and second solvation cell, and it will be the after second time it will be the mass to the one. And after closing that RDA, or you can side by side, you see the coordination number. This is the simple. RDA click করেছিস তো? তারপরে তো ওটা দেখ তার সাইডে দুটো রাখতে পারবে। So everybody completed RDA, right? So we can move on. So according to RDF result, you will see that first peak came in there. I think 1 angstrom 1.1. This is the first solvation cell. What are the interaction possibility here? There is no ion present, so there is no ionic interaction possible. In that region, there is this peak come due to the hydrogen bonding. In water, there is more hydrogen bonding formed, and the probability of the forming hydrogen bonding in 1.1 or 1.2 angstrom nearly. So this is the reason due to first peak come, and second peak also same, but it will be the reaching the less hydrogen bonding, and if the peak is near to the 1 point something, so it is the strong hydrogen bonding. From that conclusion, and each time what you have to report, there is the first solvation cell came, that's the value of the RDF, and that point distance, what is the coordination number. When you save that file, actually this clip, you will give the data in .dat format. You can open it in the text pad, and you check that distance, what is the RDF value and coordination number value, which you have to kind of report it in paper. Okay. Next is the hydrogen bonding. Same extension analysis, hydrogen bonding tab.
We want to understand what is the meaning in this mass.
Okay. We know that system contain whatever water molecule, right? So the first peak is come to nearly, that's the 1 angstrom, 1.1 or 1.2 solution cell. So 1.1 and 1.2 solution cell came due to the hydrogen bonding, because water is possible hydrogen bonding region. And the peak height is too much for the I think 13 point something. That is showing that it's the hydrogen bonding forming strong hydrogen bonding. Because it is forming the weak hydrogen bonding, the peak also shift to the right side. Suppose 2 or 2.5, because hydrogen bonding region is 3.5 angstrom beta. So it will be the forming strong hydrogen bonding. And for that paper purpose, I will recommend take that point RDF value from the DAT file, which is, and take that coordination number also, which is also given at that distance. Okay, any question about RDF curve? Next, to plot hydrogen bonding, extension, analysis, hydrogen bonding. Select. Save could be na. And what must anybody doesn't came, there is another way you can plot it. So first, write this command in Ubuntu terminal. If anybody VM RDF doesn't come, then GMX make NDX minus F ND underscore 01 go. What this command did, it will prepare an index file. What is index file? Index file are the number of atoms which will be written. Which atom you want to analyze, which atom do you want to analyze. That will be written in index file. So this is a good choice for simulation to prepare an index file. Actually, for in water, it is very easy to identify atoms. In complicated molecule, we have to create the index, and based on that index, we take that serial number, and then serial number we plot it RDF. And yeah, after clicking that, right? After that, you will write this one, atom OW, next atom HW1, atom HW2, and Q. to quit. So it will select the OW atom and hydrogen atom separately, individually. Then Q2 save and quit that. It will save in index.ndx name by default. That's case sensitive. That is the highly case sensitive. Okay, after each time you write AOW, you will see that how many group will be picking. Yeah. And Q2 save it. Then another way you can plot RDF is GMX RDF minus S only 01 here minus S. .01. Yeah. Then write this command. Actually, in GROMACS, S for TPR input, take that. A for the no PVC which is generated. N for index file which is just now created. Then O for output of the RDF and CN for the coordination number. And beam tends to how much points that width of the circle you want to consider. So you can control. And there is another terminology actually, minus RMAX 1.0. That's the RMAX command, which is the maximum distance you want to compute for the RDF. In GROMACS, by default, it takes the half of the box. Or if you give that RMAX some value, it will take that much part. After that, it will be not considered. Okay, then press enter. You have to choose that this number, serial number, which one OW serial number and HW1 and HW2 serial number. This will also give the two file, and you can plot it in Excel or whatever data, which is result is nearly similar to VMD. And that's all. Basically,
and control. So
in BMD or something there in GROMACS. So after that it will be you will select first 3, then 4, then end it to terminate it control D. It will terminate the program. Okay. Control D, I do not write it. So terminated control D. Okay. So after that, you can plot it in Excel or whatever software. Again, back to PPT. So in hydrogen bond plotting, you can use this method, and also GROMACS has some module. It also can do it. So for in VMD, the data will be the first. They can load the molecule selection, which atom do you want, by which residue name, and the donor accepted distance and the angle cutoff. Yeah. Then find hydrogen bond. Click. Then click find hydrogen bond. This is the for VMD purpose. And whoever doesn't have the VMD, they have to take the GROMACS. So GROMACS, I will write that code. What are the each one? Here.
minus
Okay. If you want to compute in GROMACS, use this command GMX H bond. A is for TPR, A for HTC, minus num for output file, and a num that's output will be the XBG format. If you compute in VMD or VMD processes that and GROMACS processes this, it will automatically choose you the system to selection. I think for your case, solvent will be the molecule, so 2,2 will be the choice. Yeah, 2,2 will be the choice. Then automatically it will compute hydrogen bond. And in GROMACS, you will see 3 column of data. First is time. Second one is the number of hydrogen bond. If you open that hydrogen bond.xbg data, and third column will be the possible acceptance or details. How many acceptor and donors present? Among them, which one is formed? Okay. Third one is not necessary. First two is necessary to plot the hydrogen bond data. Twice. Two. नहीं hydrogen bond का control नहीं होता है. Okay. So I hope we will done that. Then next thing is to calculate the transport property. To calculate the transport property, we convert the PVC to no jump, not mole. Because there you will see that the unwrapped coordinate. If you visualize that PVC, you see the molecule as well moving from the outside box. That's why it's called the unwrapped coordinate. So from that data, we can calculate the MHD. So Actually 1 and 5 हो गया. Within 10 minutes we will complete this session. Okay, done. Everybody complete? System all time. 0. Everybody completed? Zero for the system and enter. I don't want comment. Another trajectory will become, and then we will use that command to generate the MSD card, which is the mean square displacement of the atom. From that mean square displacement data, we can using Einstein relation, we can calculate the diffusivity. But not that much easy actually. There is so many Q and cons available, but you can calculate easily. Yeah. First, you need to calculate the no jump PVC, okay? Because if you not calculate, it will give some error. Also, it can be calculated, but the value will be the answer. So then after enter, you select the okay, simple water diffusion we will actually see. So you can select the 2, enter. हाँ ये कॉमन है, ऊपर वाला नहीं है. सेकेंड वाला कॉमन. No jump dot xpc image dot xpc. Actually, that time I do not remember. That's why I tried that double tab. So what are the possible? And plot. Yeah. Open text. After that, you open the Excel data and plot in open the text data and plot it in Excel. Kind of sees this kind of value, but doesn't match because in MSD it will be different for different molecules because you give different motion in molecule. So we have see that the 14 it is a linear MSD value. Here we have to calculate the gamma actually to calculate the diffusion coefficient. Gamma is the ln MHD, d ln of MHD by d ln of t, means logarithmic slope of that curve. If that logarithmic slope is equals to 1, that means the molecule in the diffusive region. From that data, what is diffusion, you take and slope, you can calculate the from Einstein calculation the diffusivity. If not get 1, you can't tell that diffusion coefficient is possible. It is either subdiffusive or super diffusive. You have to give the reason why this molecule is the subdiffusive or super diffusive region. Diffusivity is the MHD by 60. D ln of MHD by
Notepad.
okay,
Identify.
D ln of So this is the formula d ln of MHD by d ln of dt actually dt by area. That value should be 1 for diffusion. If greater than 1 or less than 1, it will be the either subdiffusive or super diffusive. You have to give the reason why it is come. Yeah. यहाँ पे थोड़ा चेंज हो रहा है वो जो छोटा सा ये विजुअलाइजेशन में पता चलता है आपका स्लोप चेंज होता है तो वो जो इफेक्ट को देखना होता है दिखना है लॉन्ग के कैलकुलेशन that from that point that small change So write that formula. I will tell you. Actually, so in MHD plot, you will see that there is a straight line, right? So throughout the straight line, the slope is similar. So we take a region from that period and take one point there and one point suppose here and calculate the difference MHD. Then we will take the logarithmic and time also. Then their ratio should be 1. It will be the diffusion region. If not 1, then it will be the subdiffusive region or super diffusive region. Actually, for water, it will be the not you encounter that problem. For when we do it the protein ligand simulation, you will see that some molecule doesn't come, some of the curve will be coming in the MHD region. There will be some non-linearity nature will become. That is for the super diffusive and subdiffusive region. So this is the end of the today's first session and end of the water simulation. Any question? Yeah.
Points you have to consider is only points which are changing.
Yeah, you just take the slope because it's linear, right? Yeah, that much came due to the number of steps. Actually, when MHD plotted, actually MHD when calculated, how it is calculated, I will tell it. Each time it take the average, right? So when you first step calculate, it is step 1. How many step 1 average? What are the step you give the simulation? 2 step, how many averages? How? half. 3-step how many average? That the data will be sorted. So initial that data will be the linear, but last it will be the go through the non-linear region. But here it will be the why it is linear, nearly linear, because the data of the water is a 3000 number of atoms is huge. So that's why it will be neglect the errors.
We break for lunch now. Check me what is pending. 15 maximum. We'll do the remaining session, and then I will also calculate out for the feedback. Please fill that up. If you requested to please fill that up and then submit it. Then after the we will take your certificate, whatever will complete.
इसके बाद इसके अंदर dash and Zero 16, 16 space 0. And density अभी यहाँ से उसके बाद लिखना है GMS.